Hello everyone. We are going to be doing piecewise functions today. Okay, and we are going to be looking at evaluating them. Right, so let's just look at an example of a piecewise function and look at how we read it, first of all. So we always have f of x equals, and then you'll see this little bracket. Okay, and then you're going to have, to the right of the bracket, you're going to have your pieces, or what makes this a piecewise function. Okay, so what makes a piecewise function is that it's broken up into different functions. So we could have x plus 3, we have 2x, we have just a number, right? And then you'll sometimes see the word if afterwards, or you'll see a comma like that. I'm just going to use if for right now. So x plus 3 if x, we'll say, is less than or equal to negative 2. Right? 2x if x is in between negative 2 and 2. And then 4 if x is greater than or equal to 2. So this is how we read this. This would be f of x equals, right? If what we're looking at, if x, we always look at this part of our function first. If x is less than or equal to negative 2, then we would use this function. If x is in between negative 2 and 2, not including the 2 because there's no equal to bars here, then we would use this function 2x. If x is greater than or equal to 2, then we would just use 4 as our function. Okay, whenever you don't have an x in your function and you just have a number, that's called a constant function. Okay, so let's look at evaluating. Right, so in my first example, we have f of x equals x plus 2 if x is less than 2, and we have 2x plus 1 if x is greater than or equal to 2. Okay? So when you have these evaluating problems, you'll be given a piecewise function like this, and then you'll be asked to evaluate a certain set of numbers. So in this case, we're going to evaluate f of 0, f of 2, f of 4, and then let's do f of 1. Okay? So when we do this, you look at this number here. Okay, 0. So I'm taking this x and I'm replacing it with whatever number is here. So I'm replacing it with 0. So the first thing we need to do is we need to come look over here. And we need to say, okay, is 0 less than 2 or is 0 greater than or equal to 2? Okay, 0 is obviously less than 2. So that means we're going to use this function. So we take this x, just like we replaced this x with 0 here, we're replacing this one with 0. 0 plus 2. Okay, it was x plus 2, and I replaced it with this 0 for 0 plus 2. Right, and then we know 0 plus 2 is just 2. So f of 0 in this piecewise function is 2. Okay, we're going to do the same thing with 2. F of 2, okay? Is 2 less than 2 or is 2 greater than or equal to 2? Right? 2 is equal to 2, so we'll use this function. And we'll replace this x with 2. So 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So f of 2 equals 5. Alright, what about 4? Is 4 less than 2 or greater than or equal to 2? Okay, well 4 is greater than, so we're going to use this function again. 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9. Okay, now 1. Is 1 less than 2? Yes, of course it is. So we'll use this function. So 1 plus 2 equals 3. Alright, let's look at another example. If f of x equals x plus 5, so we have f of x equals x plus 5 if x is less than negative 2, and negative 4 if x is greater than or equal to negative 2. So we are going to evaluate f of 3, f of negative 2, and f of negative 4. Okay? So again, same thing. You look at this number here, 3, and then you always go to the right side first. Is 3 less than negative 2 or greater than or equal to negative 2? It's greater than or equal to. Now, there's nothing here in this function. My function is negative 4. F of x equals negative 4. There's no x here for me to plug that 3 into. So my answer is just negative 4. Okay? Again, with the negative 2, it's equal to negative 2. So my answer would just be negative 4. Right? Negative 4. We're doing f of negative 4. Negative 4 is less than negative 2, so we'll use this function. So negative 4 plus 5 equals 1. Alright, so we're going to evaluate f of negative 2, f of 6, and f of 1. Okay, looking at the first one, negative 2. Negative 2 is less than 1, so we'll use this function here. 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. Okay, 6 is greater than 1. We'll use this function. Negative 2 times 6 is negative 12, plus 3 is negative 9. Okay, 1 is equal to 1, so we'll use this function again. Negative 2 times 1 plus 3. Negative 2 times 1 is negative 2, plus 3 is 1. Right. I have a couple more examples, but if you guys want to pause the video and try them for yourself after I write down the example, please feel free to do that, so that way you know if you can do them on your own. Alrighty, so in this one we are evaluating f of negative 4, f of 8, and we'll evaluate f of 2. Okay, negative 4 is less than 2. So negative 2 times negative 4 is 8, plus 4. Oh, I'm sorry. Oh, well, whatever, we'll use it. That wasn't the problem I had written down, but that's fine. So, negative 2 times negative 4 is 8, plus 4 is 12. Okay, 8 is greater than 2, so we use 4 times 8 minus 9. Okay, 4 times 8 is 32, minus 9 is 23. Alright, 2 is equal to 2, so negative 2 times 2 plus 4. Negative 2 times 2 is negative 4, plus 4 is 0. Okay, so all the examples that I've done so far have been piecewise functions that were just two pieces. So we're going to look at one that has three pieces. And you could possibly see examples that have 4 pieces to it. It's not limited. Generally, you see any 2 and 3 is what you see most often. Alright, so this one, we have 3 different functions. Okay, and then they have their boundaries on this side. Okay, and we are going to evaluate. F of -1, f of -4, let's do f of 4, and f of 5. Okay, so -1. Is -1 less than or equal to -2? No. Is -1 in between -2 and 4? Yes. So we'll use this function. 2 times -1 minus 1. 2 times -1 is -2, minus 1 would be -3. Right, -4, is -4 less than or equal to -2? Yes, it's less than -2. So -4 minus 1 is -5. Right? Is 4 less than or equal to -2? No. Is it in between -2 and 4, including 4? Yes. Okay. This equal to bar let me know that this was the function that I needed to use. So 2 times 4 minus 1. 2 times 4 is 8. Minus 1 is 7. Alright, last one, 5. 5 is greater than 4, so I will use this function. -3 times 5 is -15, plus 8 would be -7. Alright, I think we have the hang of it.